questions that are in the exam that are on each individual topic, hence why I've pulled together 4 different exam papers and got all the questions out of those exam papers on ratio, proportion, and scales. But this here will tell you on the NCFE website when I email everybody later, and I'll add you on my list now. That'll tell you what exam paper it's from, and NC means non-calculator. So as you can see, some are calculator questions and some are non-calculator questions like the one at the top. And in the real exam, obviously, it won't let you use a calculator. You can't have your calculator sort of turned on in the real exam if it's a non-calculator section. And if it's calculator question, it has to be a real calculator. Some other examination bodies, Pearson, for example, have a built-in calculator on the screen, which is helpful. NCFE, unfortunately, yet don't. So let's have a look at some of these questions. If you've got any questions as we're going through, or you think, not sure about that question, or you just want to listen, that's absolutely fine. If you do think I'm doing something wrong, or you know a different way of doing it, then also please shout out, because maths is many ways to do one question, and it's really good to see how other people have learnt maths and where they've learnt it. So people in Spain learn it different from people in the UK, from people in China, from people in Australia. Just honestly, the ways that you can do questions, it's really fun to see that lots of people learn things different ways. So like I said, all these questions are on ratio, proportion, and scales. Let's start. Oh, what is that doing now? Optimizing. I just want my pen to work. I'm moving it out of the way. Okay, that's my pen work. There we go. My pen is now working. Oh, it's not. Why is my pen not working? Oh no, it is working. How bizarre. Okay, let's rub that one out. Okay, Mr. Aldridge wants his students to compare the temperatures of the planets. He reads that the mean temperature on Mars is -65. The ratio of the mean temperature on Mars to the mean temperature on Pluto is 13 to 46. So we've now got Pluto he's mentioning now. That's Mars. It doesn't tell us what the temperature is, because it says here, Mr. Aldridge thinks that the mean temperature on Pluto is 275 degrees colder than the mean temperature on Mars. So if we're going to make that temperature colder, if we're thinking about temperatures, I'm going to say 100's there, and then -100 is about there. So we're on -65. Colder than -65 is taking it that way. So that's 0, and that's boiling. So if we're going colder than -65 by that many degrees, we're simply going to add, and we'll do it over here, -65, add another 275 to it. We're literally going to be saying that it is -340 degrees. So we've not earned ourselves any points yet for this question, but we know that he thinks that the mean temperature on Pluto is -340. And that's not the answer, because he thinks that. And is he right? It's saying, is he right? So it's a yes or a no question. So we've got a ratio here of 13 and 46. If 65 represents 13 parts, we need to know what 46 represents. So if we look at this relationship between these two numbers, it's non-calculator, by the way. So we're thinking, ooh, this is a tricky question because I can't use my calculator. So we're going to go 65 divided by 13. Because we've kind of done up to 12s at school, if we did 13's times table at the side of the paper, we'll see that 65 has a direct relationship with 13. It goes into 13 5 times. So for every 1 degree here, we can see that Pluto would be 5, because that number here is 5 times bigger. Hi, Richie, sorry. So all we need to do here now is look at the relationship between 46 and 5. So we've now got 13 pieces into 65, and we're going to just multiply this number by 5. And I know it's minus, but we'll put the minus in a minute because it's minus here, look. So we're going to go 6 times 5 is 30, and then 4 times 5 is 20, add our spare number on the bottom, which is 3. So we can see, and it's a minus, because we're doing minus here, aren't we? Because that's minus 65 there, so, and a positive divided into a negative is a minus. So we can see, and then that will be like that. Minus 230 is the temperature on Pluto, so we have worked it out correctly to be minus 230. Mr. Aldridge said it was going to be minus 340. Is he correct? No, he's not correct. So for our final mark here, for the fourth mark, you must make sure you've put a yes, in this case a no, yes or a no, in the answer box. I get a lot of people that submit questions and they might have just put minus 230 in the answer box, but not told me yes or no, which is really good maths, really good maths. You've worked it out correctly, but you're not going to get that fourth mark. You would probably only get 3 marks if you'd done all of that and not put no in. And so really, when it comes to these sort of questions, make sure you've written yes or no quite clearly in there. And I'm going to start off by saying, Nahira, that's probably one of the toughest questions that is going to get for a non-calculator. So if you're thinking at the minute, oh, that's too complicated for me right now, that's absolutely fine, because the more we kind of have these sessions, and if you come to like some support sessions, you'll find that we look at these sort of questions on a lesser scale and build up to something like this. This is an exam question. If it's your first day, you're kind of some way away from your exam. Okay, and likewise with you, Mansur, if you've got anything to ask, please just shout out. And I know you do anyway, so that's fine, just shout out. Eric wants to mark out the plot for a long jump. This, I don't know why, when I printed this screen out, I didn't click on that little arrow because that would have gone that way. So at the minute, my grid is not large enough. And I remember this last time when I did this question, I thought, oh my God, what a mistake I've made. So Eric wants to mark out a plot for a long jump in one of the sections. It is the shape of a rectangle. So we're going to rectangle. I'm not going to write it on there yet. 32 by 3. And a distance 10 meters away from the running track. So the running track's down here somewhere. So that's going to be 10 meters. Okay, so we've written our numbers in there. We've taken all the information we need from that, except for the scale. It's saying on this here, each square is 1 by 1. So that's quite straightforward. We can see that's 1 by 1. So, but it's saying on the map, or we'll say, yeah, on the map, we'll say map, is 1 centimeter. In real life, it's saying that's 200 centimeters. So 200 centimeters. If we know that every 1 meter equals 100 centimeters, we can clearly see that for every 1 centimeter on our map, it's representing 2 meters in real life. So we've got our scale done now. So we've probably earned ourselves 1 point because we've worked out the scale. We just need now to draw it. And what you would do on this exam, you'd click on this tool here, that one there, and then you'd grab that square and you'd make it big. But if we can see here, we need 32 meters. Okay, that's in meters, and that's in meters. We said here that every two meters is 1 centimeter. So we divide that by 2. We can see that's going to be 5 centimeters. We divide that by 2. We can see that one's going to be 1.5 centimeters. And we divide that one by 2. And we're going to make that one 16 centimeters. So we can now see our scale from real life onto our map was clearly just divide by 2. 200 on there, but that's centimeters. So in real life, it's 2 meters. So that's helped us a load. We can now say that 1 centimeter is 2 meters. So we've got to be 10 meters or 5 centimeters away from the running track. 1, 2, 3, 4, 5. So it has to be here. So I'm starting there. No closer than that. And it's 1.5 meters, 1.5 centimeters wide. So that'd be there, like 1.5 squares. So that's our running track. And then it's 16 centimeters long. I know I've done this before because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, about here, 16. And I remember that last time. So if on the question, you could click that little arrow that I'm going to drive past now there, and it disappears. The whole thing becomes a nice grid. And when you pull that tool there and drag it along, it's not all wonky like mine. It's a straight pull. It doesn't say, let's have a look, use your drawing and show a possible solution of a plot. It doesn't say we've got to label it. Sometimes it'll say, can you label your diagram? It doesn't say that. We've put that there. It's a minimum of 10. It's 10 meters away from the running track. Yeah, 5 centimeters. It's 1.5 wide, which is 3 meters, and it's 16 centimeters long, which is 32 meters. So that would be the running track question. That's a calculator question. We don't need a calculator for that one, but it's just the understanding of the scale here. And I tend to say real life, purely because you're looking at the left-hand side number is always the map, and then the second number is always real life. So map, real life, and then you can kind of create, well, not create, but narrow it down from 200 centimeters into 2 meters. And hopefully that one was okay. So this was a question that somebody else highlighted to me yesterday. And it's a tricky question, but only because there's some big numbers going on here, but it's a calculator question, so that shouldn't really hinder us too much that it's talking big numbers. So for starters, when I'm seeing that question, I'm saying map, 1 centimeter, real life, 125,000 centimeters. That's a lot. We just said for every 1 meter, it is 100 centimeters. So if we divide that number by 100, and we can use a calculator, we're then going to get 1 centimeter on the map equals 1250 meters. And the reason it's like that is because if I was to show you on, oh, where's my calculator gone? Maybe I didn't open it. I thought I opened my calculator. I'll open it now. When you're dividing by 100, we just literally take 2 zeros off the end, especially when it ends in all those zeros. So we've just literally divided it by 100. So we've taken off 2 zeros. There we go, 1,250. What I would say is if it didn't have zeros on the end, we just move the decimal place 2 places in from the left. So we could keep it at that. We could 100% keep it at that. But what I'd like to do is carry on reading the question. And it now says that we're talking about kilometers per hour here. Kilometers, houses in meters. So the easiest way of carrying on this question is say that 1 centimeter on the map equals, and then to get from 1 meter equals 1 kilometer, sorry, 1 kilometer equals 1,000 meters. So we're going to divide this number again by 1,000. And that's going to give us 1.25 kilometers. We've now got our scale. Look, we've now changed it from something that looks quite daunting. That's map is 1.25 kilometers in real life. So we're good to go. The distance along the road between the airport and the resort is 51.2 centimeters. So if we times this number by 51.2, because it's in here, that says 51.2, we're going to get our number here. Look, because every 1 centimeter is that we want it 51.2 times bigger. So we need this number 51.2 times bigger. So we're going to times that. Let's get my calculator back open. So we've got our 51.2 multiplied by 1.25 equals 64. So we can see that on the map, when it says 51.2 centimeters, in real life, it's 64 kilometers. So all we did with that one is looked at the relationship here. We saw that it was 51.2 times bigger. That was 51.2. So this one had to also be 51.2 times bigger. So we just multiplied it. We set it out like a direct proportion question, and we did them both multiplied by the same number. So we now know that the distance, so we're thinking of something else now, distance, speed, and time. So that little triangle is something that you won't get given on your exam paper. But what is important to remember is that as long as you put D at the top, these two can be either way around. It doesn't matter. Because D at the top is your major number, because you divide D by S to get T, and you divide D by T to get S. And if you want distance, you multiply the two at the bottom together. So as long as you get D at the top, you can kind of see that it's dividing by that line there. I always see that as being it's dividing by the number below. So we've got the distance, 64 kilometers, and we can see she's going at 80 kilometers per hour, and we want to know how long. So distance divided by speed equals time. So 64, and again, it's a calculator paper, so I'm not about to do that on my head. 64 divided by 80. If we did 64 divided by 8, we're going to get 8. But so 64 divided by 80 is going to be 0.8. But again, it's a case of use your tools while you've got them available. There's no point thinking, oh yeah, I can do that in my head, and then thinking, oh, actually, no, I can't. I've wasted a bit of time. So it's 0.8 of an hour. 0.8 hours. If I was to be told I'm going to take 0.8 hours to get a taxi, I wouldn't really know what that is. 0.8 of an hour. It's not, it's 0.5, that's half an hour, yeah, and 1 hour is an hour. So I'm going to tell, I would suggest that we would say 0.8 times by 60, because there's 60 minutes in 1 hour. And then it's going to tell us that how long in minutes. If you kept your answer as 0.8, I am 100% saying that the answer would be accepted by the examination board. I'm just making it a step further because I'd also accept 48 minutes. And it just looks neater. But again, in an exam, when you've got less time than you think, putting 0.8 of an hour is absolutely acceptable. Move on to the next question. I'm just tidying it up and making it into minutes. And again, that's quite a difficult question because it's big numbers, and I think the way it confuses people is because you're talking centimeters, you're talking miles per hour, so it's about how to make that number into what you're using here, how to make that into kilometers. Had you done it a different way, and again, if you're looking at that question, think actually, Steve, I'd have times that number by 51.2 to find out the big number. So 51.2 multiplied by 125,000. We know that the distance in real life is 6.4 million centimeters. So we could have then shrunk our number by dividing by 100 to get to meters, and then divide by 1,000 to get to kilometers. You'd still get the same answer. So it doesn't matter which way, whether you shrink your number at the start, which we did here, we shrunk our number at the start to have that scale, a really easy scale to read, or whether you do your multiplication of centimeters by centimeters, keeping it at centimeters, and then change it to kilometers at the end, it matters not. You're still getting 64. And that's what I said about why I enjoy maths so much, is because if I do a question 4 times, I might do it differently 2 or 3. I won't do this. I won't do the same method each time, but it's just the way your brain's wired. You know, you kind of think, oh yeah, I could have done it that way. Oh, I could have done it this way, and you do it that set way. There's certain questions where I'll do the same every time, where it's ingrained in my brain, where somebody's told me something when I was a younger person. Okay, another drawing one, and for me, this one brings back school memories because we used to get paper like this, and it's like, oh my god, we've got a 3D paper. This is amazing. you would choose that tool here on the exam, and we're going to draw this shape. It's saying 1 centimeter is 10 centimeters. So we would divide each of those numbers by 10 to find out how big it's going to be on our sheet of paper. So we know that one's 5, that one's going to be 6, that one's going to be 8, and there's one here that's going to be 9. So we're already talking 5 and 6 centimeters, but I would definitely start somewhere near the bottom to try and keep, and once you've got the line tool, keep it in there because it makes it go straight, whereas I'm going to do it free on 1, 2, 3, 4, 5. Not straight to start with, that's a rubbish start. Okay, but I've done that line there. Then I'm going to go along 6. Oh gosh, I'll do it from here. 1. Oh, no, let me start again. Oh my God, let me scroll up my page a little bit. That's it. Might be okay better now. Probably won't, but all right. So again, that's why using the tool on the exam is much better than using this tool, because 3, 4, 5, 6. Okay, so I've done the front, and I've done that bit here. Now I'm going to go up 8. Wow, up 8. So from here, 1, 2, 3, 4, 5, 6, 7, 8, and the same at this point. 1, 2, 3, 4, 5, 6, 7, 8, and the same at this end. 1, 2, 3, 4, 5, 6, 7, 8. So I've now got this bit, and this bit in there, and I'm going to draw my line here because that's where my wall finishes and where my roof starts. Go. Now I've got my other bit of roof to do. As you can see, it goes up 9 in the middle. So my middle number is 3. So I'm going to go up 9, 1. And I'm not going to actually draw the line because I'm just showing you that the apex on the roof is higher. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I'm going to draw my line from there to that one and there to that one. And likewise, I'm now going to go back again 5. 1, 2, 3, 4, 5. Not the greatest. Definitely not the greatest. Right. Okay. It's not the best drawing when it's freehand, and when you're using the tool, it can be a little bit fiddly, but it looks neater than that. So what I would say, like you said there, click the tool and then go for it. Do you need to use your notepad for your working? I'd always have a piece of paper next to me and an empty piece of paper at that when you go into the exam. Purely because I don't need to draw anything on here. I know that dividing by 10 is simply just getting rid of the 0, so I don't need notes for that. So yeah, I don't know why you would need a notepad for that one. It's non-calc, but dividing by 10 at level 2, it should be pretty straightforward. Okay, a tricky question again. We're talking all sorts of numbers here. Look, I can see gallons, I can see tablespoons, I can see grams. So when they're talking about these sort of measures, when it comes to conversions, it can be quite confusing. So the way I wrote that one down above, and I'm going to write this one in the same method, it's really important that you try and keep things in lines and columns. Right, a typical hot tub holds 309 gallons of water. Chlorine needs to be added to the water, 250 gallons. So we're going to put here, hot tub. 250 gallons is, so tablespoons, we'll put TB, tablespoons, 1.5 grams, gallons, grams. Okay, and it says here 1 tablespoon equals 14 grams. Okay, we need, it says here that 250 gallons needs 1.5 grams, 1.5 spoons, my goodness. Spoons, 1.5 spoons, 1.5 spoons. Okay. It's saying 1 spoon here is 14 grams. So if we, first of all, we will find out what 1.5 is. If we go 1.5 there. So we've added half on again here, look. So 1 to 1.5. So we need to add half on again there. So half of 14 is 7. Add that on to our 14. We can see now we've got a better way of talking about it here now. We're not talking spoons because it says grams in the question. So we now know that a hot tub, if it's 250, is going to be 21 grams. So we can put grams here and we can put gallons there. We need 309 gallons. So we can do We can look at relationship here and do the same to this number, or we can look at the relationship here and do the same to that number. It's once we set it out like this, where we've got a missing number, we can quickly work it out. Let me just get rid of that circle there. So, as I say, there's three ways of doing this, and we'll have a look at each one, because again, some people might be seeing it one way. So first, I'm going to look at this relationship here. So I'm going to look at how many times 21 divides into 250. Okay, so I've got a big old number there. I know it's 11.09 times bigger. I can see it here. Look, so that number here is 11 times bigger. So if I divide this number by 11.9, let's go that way. 309 divided by 11.9. I've got 25. Because it had that little point bit on the end, it's 26. So I'm putting 20. So if I put 26 here, oh, it's gone. Where's my pen gone? Right, so if I put there 26, that's that way when I've done that number divided by that number and the same relationship. If I do this number, the relationship here, look, again, I'm going to do the same. Oh, where's that gone? My pen's gone on my calculator. I'm having a bit of a wobble. Right, so how many times? Let's go 309 divided by 250. Okay, what? 250. So we can see it's 1.236. So that's a better number than what we had before, where it filled the calculator screen. So now, if we do that number times by 1.236, so times by 1.236, times by 21, what an idiot, 1.236, was it? Yeah, I think it was times by 21. There we go. There we go. So we got the same number again. That's nearly 26. So we're going to put 26 grams of chlorine in our pool. If we did it a different way, and I'm not trying to baffle anybody, but if you've been to any of my lessons before, you might think that I refer to a primary school window, and I've got four numbers. Okay, let's go here, primary school window. And let's go 309. So how I do this, I'm going to go this way round. It's going to equal that number here. So I'm going to go 21 divided by 250 times by 309 equals that number there. And again, that's the third way. So instead of looking at the relationship between that way or that way, we put it in our calculator as one go. 21 divided by 250 times by 309. And it's that number again. So we've done it three different ways, and we've got the same number each time. If I'm writing my answer in, it doesn't say round it up, but you would get a mark for putting 25.596. You'd also get a mark for putting 25.6 because you've rounded it up to one decimal place. It's two decimal place, but one decimal place. And then you'd also get a mark for writing 26 because the examiners can see you've got the right methodology, the right process, and they would accept either of those answers because you've shown, if you've written that one, you've rounded your number up to two decimal places in that you've made that number bigger here, so it becomes 60. And if you've looked at nearest whole number, you've rounded it up to 26. So three different ways to work out the same question. Can be quite confusing, but again, the more we practice, the more you can see how things are done that are comfortable to you. You might think, oh yeah, I used to do it like that years ago. Oh yeah, I've seen that method before. Or you might think, whoa, that method is absolutely crazy, Steve. What are you doing? I can do it this way. So please, please, please don't think of it as my way being the right way. My way is one way. It's not the only way. Okay, Matt joins a cycling club. And that's a bit small. Can I make that a little bit bigger? Sorry about that. I'm going to make it a little bit bigger. That's better. Right, Matt joined the cycling club. The coordinator, the 1 centimeter coordinate grid shows Matt's position of his house. Here, the scale of 1 to 50,000. The cycling club is 2.5 kilometers south of Matt's house. So south, if we're talking naughty, elephants, squirt, water, or never eat shredded wheat. Don't matter. So we're going downwards. We're going down, directly straight down from Matt's house. On the map is 1 centimeter. In real life, it's saying 50,000 centimeters. Okay, we've just done scale a minute ago. We divide by 100 to get centimeters to meters. And then we divide by 1,000 to get from meters to kilometers. If we wanted to divide by 100,000 and get rid of it all in one go, we could do that. But I find it easier because I know that there are 100 centimeters in 1 meter, and I know that there are 1,000 meters in 1 kilometer. But people could say, oh, actually, why don't you just times those two together? Yeah, 100,000, and then divide that by 100,000. You've got your answer straight away, Steve. Yeah, I have. But again, it's that 2-stage process where it's real life. I know meters and centimeters. So let's do it in real life. And it does work the other way around. It's just a case of recognizing. Can I make that a bit bigger than 50,000? So 50,000 centimeters in real life. Divide by 100. That's how many meters I've got. 500 meters. And then I divide that by 1,000. And I'm in kilometers now. So I'm in kilometers, 0.5. So I know that 1 centimeter on the map is the same as saying 0.5 kilometers in real life. If you want to do that one where I said before, where you times both of these together, you can do 100 times 1,000, which is 100,000. Yep, we know it's 100,000. And we go 50,000, 1, 2, 3, divided by 100,000, 1, 2, 3, 4, 5, and you're getting the same answer. So again, processes. Maths is all about process. It's how you get to the end point. People follow different processes. As I say, I like chunking these sort of questions up because I know how many meters are in a centimeter, how many millimeters are in a centimeter. You can kind of work out that way. So we now know that every 1 centimeter is 0.5 kilometers. It's 2.5 kilometers south, half a kilometer, 1 kilometer, 1.5, 2, 2.5. And where is that? That's a cycling club. Cycling club. Does it say label it? It doesn't say label it, so I didn't need to write cycling club on there, but I just put an X marks a spot. It's 2 marks for X marks a spot, 1 for working out your scale and 1 for putting the X in the right place. We got a couple more. Brilliant. Charlie plans a road trip to America, across Route 66 in America. He looks at these flights online. Charlie thinks that the afternoon flight has a higher proportion, higher number, basically, of seats available in is Charlie correct? So it's a yes or no for the second mark. So we must remember to put a yes or a no in there. When we see numbers like this, and with the word proportion, we can quite easily go morning flight. I'm going to go along here. Morning flight. So we've got available seats 338 out of 416. Afternoon flight. That's morning, by the way. Afternoon flight. Same thing again. Available seats 396 out of 528. When I look at those two fractions, so now fractions, we know that's a proportion of that number, and that's a proportion of that number. I don't know which one's bigger by looking at those fractions. I haven't got a clue. So the best way to do is change these fractions into decimals. And we do that by dividing top number by the bottom number. And we've got our decimal straight away. So clearly now it's a calculator paper look. So we would have use of our calculator. 338 divided by 416 equals 0.3 0.8125. 0.8125. That's the morning availability. The afternoon availability, we do exactly the same. Top number 396 divided by 28. 0.75. Who would have known that? Well, it's 3/4. Not me, not from looking at it anyway. So we now can see that the morning flight has a higher proportion of seats available. There's 338 available out of 416, and we now know that that is 0.1825. He thinks that the highest proportion is the afternoon. He's incorrect. He's not correct. So not correct. Oops, not correct. Right, not correct. I was trying to write that. All sorts going on there. So it's not correct because we can clearly see that the morning has a higher number than the afternoon. Looking at the fractions, we wouldn't be able to tell unless you're really super good at fractions, which is not our strength.
What if you just, Steve? What if you just subtracted the numbers? Would it still make sense, or do you have to find the decimal?
No, because it's if you just did 416 take away 338, you'd have just the number of seats available. But don't forget, this plane's bigger. So even though there might be more, so what is the actual number when we do that? 416 minus, I mean, for this one question, you might get lucky and it might work, but let's have a look. That's 78. So 78 seats unavailable on that one. And then on this one, 528 minus 396 equals 132. So that's, if you're looking at that one, it's saying that there's basically 132 seats sold, or the difference between those numbers is 132. So you'd probably say, oh yeah, look, it's a higher number as the afternoon. So that's maybe where Charlie's kind of, that's what the questions try to trick you into thinking, that if I just find out the number of seats that are taken and get us the highest number. So yeah, when you've got proportion questions, my advice would be to always write as a fraction as you see it. So we just put that number over that number. So that's the total, that's the denominator. The total number is always the total number of pizza slices. And then divide the top one by the bottom one to get your decimal. If it said, oh, show it as a percentage, we just times that by 100, and that becomes 81.25, and that becomes 75. But it's not asking you to do it as a decimal or as a percentage. It's just asking you which is the highest proportion. So yeah, it's identifying the best way to work that one out, and thinking, right, it's asking me about proportion. It's asking me about, it's not probability, it's proportion. So think of like who's got the most slices of pizza left. When you've got huge pizza, there's 416 slices. It's not like an 8 slicer where we can just, if you shrunk those fractions down, I'm trying to think, would I have done it that way? You would have eventually got to 3/4 on that one, but I'm thinking of that one. What would the smallest that one goes? Obviously divide by 2 remains the same. Divide by 2 again. So we divide that one by 2. It's going to have an 8 on the end. It would have been longer. So just by doing a decimal straight away, we can clearly see that that one is bigger. And again, it's those sort of questions that pop up and give you if I sort of look on like the topics, there's about 25 topics, and each exam there's about 20 that come up. So there's 5 topics that don't actually come up. There are certain topics that come up every single exam, and what we would do, we could look at the printout of your past result and say, right, that's come up, that's come up, that's come up, that's not come up, that's not come up. You could look at kind of hot spots that are definitely coming up every time, and you could look at questions that are maybe not coming up every time, or you might think, oh wow, I'm really good at that, and that's come up every time. Oh, I'm not so good at that one, and that's come up every time. So we could look at that. I've done it with a few people where we've kind of gone through past results. Charlie travels from a hotel to the start of Route 66. So another one here where we've got 50,000. So straight away, is it the same paper? So look, that one is 2132. It's not. No, I'm going to say we could just go scroll back up on the exam, but you can't. But again, we're seeing here the same one. So we know that 1 centimetre on the map is the same as 50,000 in real life. So to get that, we keep that one set at 1 centimetre, obviously. We divide by 100. Okay, so divide by 100 is going to give us 500 meters. Let's say that 1 centimetre. We divide by 1,000, and that's going to give us 0.5 kilometers. It might ask us if something else. So let's have a look. The distance he travels is 0.8 meters on the map. Okay, so it's springing the question the other way. I quite like that one. That's a cheeky one. So we have to think about what is 0.08 meters. So if we think I've got 1 meter is 100 centimeters, I look at that number and think, right, so if that is 0.8, that is 80 centimeters. 0.8. So now 0.08 must be 8 centimeters. That's saying that's 8 parts of 100. 8 parts of 100. So it's 8 centimeters. So he's saying that he travels 8 centimeters on the map. How far is it in real life? So we've just worked out that whole scale, and we know that that is 0.5 kilometers. But it's asking it in meters. So we did it one too far. In theory, it's asking you for this one. That's okay, because we did it twice. We did it in that one. So it's saying that for every 1 centimeter, it's 500 meters. And he's gone 8 centimeters, because that's 0.8 meters. So if you look at that one there, we're just going to times this one by 500. Yeah, that one's going, that one to that one is 500 times bigger. So this one to this one is 500 times bigger. Yeah. So let's go. Let's go 8 times 500. 8 times 500. Why are we doing 8 times 500? You know, 8 times 5 is 40. So 8 times 500 is 4,000. Meters. So I would have probably not read all that question and probably end up putting that for my answer, and then have to read back and think, oh my God, it's only worth 1 mark. I've done it wrong. And so if you wrote 4 kilometers, you've got the right answer, but not how they're asking you. So you wouldn't get your 1 mark. Unfortunately, you've gone too far with your scale. So as much as you've shown great maths and you've worked it all out properly, because you've written kilometers and not in meters as it says, you wouldn't get that mark, which is a real pain, because I didn't know it. As I say, I'm one of those people that starts doing the math straight away, and I'm thinking, oh yeah, I've made a mistake loads of times where I've not written in the right format. Okay, last question. We've got through these really well, actually. That's really cool. Recruitment agency. Jake is an apprentice at a recruitment agency. The table shows information about applicants last month. Success rate is a proportion. So we've had proportion word before, of applicants who are successful. Work out a percentage. So above, when it was talking about plain seats, we didn't get it to the percentage stage. We got it to the decimal stage. So it's saying here there's 15 as a fraction of 80 people that are successful at getting a job. So we know to get a decimal, it's top number divided by bottom number. That equals the decimal. And then to get a decimal to a fraction, a decimal to a percentage, that is simply times that number by 100, because we want the mark out of 100. Percent is 100. So we're going to do 15. Where's my calculator? Have I just closed it down? I don't think I have. 15 divided by 80. That's our decimal. So we wouldn't get a point for that because it's asking you for a percentage. Times it by 100. And we've got 18.75. 18.75. And that is the answer. If you'd have left your answer at the decimal stage, you might have got 1 mark. But once you've got to the decimal, the percentage part is easy because you just any decimal you've got, you times by 100 to get to the percentage. If you've got a percentage and you need to get to a decimal, you divide by 100. And what I could say is that kind of triangulation of fractions to decimals to percentages is not three different sums in theory. It's one number represented three different styles. So if we're saying 1/4, then if we've got 1/4 as a percentage, a quarter is probably not a brilliant example, but a quarter is 25%. And then as a decimal is 0.25. So they're all the same amount. It's just how they're presented. So when we've got sums to get from fraction to decimal to percentages, it's the same number. It just looks different. So it's all about recognizing what is it asking me to do it as a percentage. Is it asking me as a decimal? Is it saying as a fraction? And it's about putting those numbers in that order and working your way around. If you need to get a percentage and you got a fraction, then you divide top by bottom, make sure you got your decimal, times by 100. But the more you do these, the better. If you want to have a go, and let me just get onto the website, at any level 1 or any level 2 paper, let me just log out as me. Actually, no, I'll log in as no, I won't log in as me. I was going to show you on Atom, but on Atom there's the assignments. They're okay. Don't get me wrong, the assignments are absolutely fine. They're just not exams. They're not. They're in the style of the exam and they're at the same level as the exam. But the more practice you get at seeing these exams, I've just taken the ones we've just done today in the session are all taken from these four at the bottom. So all those questions we've done today appear in one of these four. And the more you get exposed to these exams, it's not going to make you any less prepared for the exam question, for the exam topic. When I say topic, it could be beekeeping, it could be space, it could be train driving. It'll get you more familiar with the process of, oh, wow, it's asking me proportion, oh, it's asking me mean, because the same wording is used in every exam. It's just asking you about a different story. Painting. Are we painting? Are we collecting apples? Are we looking at miles on a motorway? So the process is really important. So the more you can expose yourself to the exam papers, the better. And by the way, if you do these exam papers, they don't mark themselves. The best thing to do is open the mark scheme first. Say I'm going to attempt that one. That's the mark scheme now. Keep it open. That's done. And as you're going through, maybe do 4 or 5 questions and then have a look at the answers. Because if you get to the end, and we'll just quickly grab in the end. If you get to the end, next question. I'll say there we go. That's the exact question we finished on. How spooky is that? That is, wow, that is really quite spooky because there's hundreds of questions and we've picked the same one we just finished on. So if you get to the end of this exam and you think, oh yeah, this is going to go to Steve, it's not. This is NCFE, not me. It just disappears and it goes into cyberspace. And once you finish test, it's gone. You can't find it. So mark a couple of questions as you're going along. If you're stuck on any particular question, I'd suggest take a picture of it on your phone and say, Steve, this one was absolutely driving me mad. How do I do it? Or what is the way around it? Because once you've submitted it and you can, oh yeah, it was that question. Which question? You know, there's hundreds of questions. So please, if you come across any sticky ones, just shout out, and I'm happy to have a 5-minute catch up, a 10-minute catch up, an hour in a full session. It doesn't matter how long it takes. I just want people to get exposed to that style of question. All right, any questions? Because I've gone on for an hour. Any questions? Are we kind of like, that was quite tricky, that was quite hard, that was quite easy? I'm not sure. Nahira, first one, have I kind of like scared you off, or are you going to come back later on another time and think, you know what, I'm going to keep on going with maths. I'm all right at it.
Oh, yes.
You're okay, brilliant. And Moansa, obviously we've had a go, so it's a case of how can we kind of get that preparation